In section 3, day 1, we added, subtracted, and multiplied binomial radical expressions, and today we're going to divide. In order to divide binomial radical expressions, you have to rationalize, and we'll use the conjugate to do so. Anytime you have a conjugate of radicals, it's a little different than the conjugate of imaginaries. In radicals, you just change the sign in the middle. So even if you have an expression that says something like the square root of 3 plus 2, its conjugate is the square root of 3 minus 2. You don't have to worry about the sign in front of the square root. So just a quick recap on multiplying conjugates. In multiplying conjugates, because they're binomials, you're technically foiling. But what happens is, in foiling, the outer and inner terms will end up canceling. And so all you really need to do is the first times first and the last times last. The first times first in this one gives you 1. And the last times last in this one gives you a -5. And 1 minus 5 is -4. You can only use this foiling shortcut when they are conjugates. If they're not conjugates, you cannot use the shortcut. So the shortcut in number 2, because 2 minus root 8 and 2 plus root 8 are conjugates, you can just do first times first, which is 4, and last times last, which is a -8. And 4 minus 8 is -4. The fact that those answers are both -4 is just a coincidence. So we're going to use conjugates to rationalize denominators that have 2 terms. In number 1, you're going to multiply top and bottom by 1 plus the square root of 5, because that's the conjugate of the bottom. On the bottom, you can use the shortcut. First times first means 1 times 1, which is 1. And last times last means -root5 times +root5, which is a -5. In the top, you have to distribute. So I'm going to give this 2 to both the 1 and the √5. 2 times 1 is 2, and 2 times √5 is a +2 √5. All you need to do is combine those things that are the same and then simplify or reduce. So what I end up with is a 2 plus 2 √5 on the top and a -4 on the bottom. In order to help us reduce, we're going to take that -4 on the bottom and give it to everybody up top. So we have 2 over -4 plus a 2 √5 over -4. What ends up happening is that some of these things reduce. And when you reduce, you're left with a -1/2 minus a √5 over 2. Because technically speaking, there's a 1 in front of that. You don't have to write it. In fact, most people wouldn't. Number 2, the conjugate of the bottom is √3 minus √2. We'll do the bottom first. Because those are conjugates, you can do first times first, which is 3, and last times last, which is a -2. This denominator ends up being 1, which isn't necessary, so from here on out, we're going to ignore it. On the top, I'm distributing a √5. √5 times √3 is √15. √5 times a -√2 is a -√10. You always have to double check to see if you can simplify those. 15 is not a perfect square, nor is it one of the numbers on the perfect square list. And 10 isn't a perfect square, nor is it able to be written as one of the numbers on the perfect square list. So they can't be simplified. Your final answer is just √15 minus √10. And just a quick reminder from the other lesson, you can't combine the two of them because 15 and 10 are not similar radicands. Number 3, we're going to multiply top and bottom by the conjugate of the bottom, which happens to be 1 plus the square root of 5. So on the bottom first, use the shortcut because they're conjugates. 1 times 1 is 1, and -√5 times a +√5 is a -5. On the top, this one's a lot more complicated than the other two because they're both binomials. You're forced to FOIL, and there's no shortcut here because they're not conjugates. 2 times 1 is 2. 2 times √5 is a 2 √5. Root 5 times 1 is another root 5. And root 5 times root 5 is just 5. Combine your rationals first. 2 plus 5 is 7. 2 root 5 plus a 1 root 5 is a 3 root 5. And on the bottom, 1 minus 5 is negative 4. Uncommon denominator that gives you negative 7 over 4 minus 3 root 5 over 4. Neither of which can be reduced. Number 4, we're going to multiply top and bottom by the conjugate of the bottom, which is root 3 minus root 2. Because the bottoms are conjugates, you can use the shortcut. Root 3 times root 3 is 3. And root 2 times a negative root 2 is a negative 2. Which is good because, again, here the denominator is 1 and you can ignore it. On the top, you're forced to FOIL. Root 27 times root 3 is root 81, which I'll fix in a second. Root 27 times negative root 2 is negative root 54. Negative root 2 times 3 is a negative root 6. And negative root 2 times a negative root 2 is a plus 2. So again, I'm going to ignore this part because it's really just a 1. I'm going to focus on the top for a second. The square root of 81 is just 9. And the 54 isn't a perfect square, but it can be rewritten using numbers on the list of perfect squares. So the 54, according to that list of perfect squares, can be rewritten using a 9 and 6. And the square root of 9 is just 3. This is getting a little more complicated, so I'm going to rewrite what we really have. We have 9 minus 3 root 6 minus root 6 plus 2. And don't forget the denominator went away. So 9 plus 2 is 11, and negative 3 root 6 minus 1 root 6 is negative 4 root 6. And that's your final answer. Your goal when you're done all of these is to make sure that there are no radicals in the bottom.